We're going to work on solving log equations. To solve a log equation, we convert to exponential form. We'll start with log of x equals 0. Notice there isn't a written base. This is a common log. The base is actually 10. If you need to write it in, you can. In exponential form, we have 10 to the 0 equals x. Anything raised to the power of 0 is 1, so x equals 1. Similarly, if we have ln of x equals 1, this is a natural log, which is the same as log base e. If you need to write it that way, that's fine. Converting that to exponential form, we have e to the first power equals x, or x equals e. Next, we'll consider log of the quantity x plus 2 equals 1. Again, the base is 10. It's not written. So in exponential form, we have 10 equals x plus 2, a basic linear equation. We can subtract 2 from both sides, and we get that x is 8. Or we can write x equals 8 as our answer. Here's one where the log has a different base. It's a base of 5 of the quantity x plus 3 equals 1. We do this in the same way. In exponential form, 5 to the first equals x plus 3. Subtracting 3 from both sides, we get x equals 2. In our next example, we're going to have more than one log in the equation. And we'll have to use a log property. So we have the log of x plus 1 plus the log of x minus 1 equaling 0. Now in this case, we have to use a log property to rewrite it as a single log expression here on the left. And then we can convert to exponential form like we've been doing. You can FOIL that out now, before you do this, or after. I'm leaving it here just so you can see the form. So 10 to the 0, yes, you could write 1, equals, when you FOIL this out, x squared minus 1, or 1 equals x squared minus 1. Adding 1 to both sides, we get x squared is 2. Now, algebraically, we get two solutions, a positive and a negative answer. However, we can't take a log of a negative number, so we have to rule out negative root 2. Next example, log of x plus log of x plus 3 equals 1. Step 1, use log property that when you have a sum of two logs, you can write it as a log of a product. And that equals 1. You can FOIL it out and distribute now or later. This time I can distribute inside if you want, to show you that both ways are fine. Unwritten base, it's a common log. 10 to the first equals x squared plus 3x. This is quadratic, so we're going to subtract 10, set one side to 0. X squared plus 3x minus 10. Two numbers with a product of negative 10 and a sum of 5 is 5 minus 2. So we have two algebraic solutions. But if we look at the original equation, we can't plug in or substitute a negative 5 because we'd be taking a log of a negative. So once again, we must rule out an answer, and we get x equals 2. Our final example, we'll have log of 2x plus 5 plus the log of x plus 1 equals 1. Step 1, we want to rewrite it as 1 log log over product. Then convert to exponential form. So we have 10 to the first equals 2x plus 5 times x plus 1. If we FOIL, we get 2x squared plus 2x plus 5x plus 5. Combining like terms on the right-hand side, we have 7 x's. And this is quadratic, so we want to subtract 10 from both sides. We're going to use the quadratic formula to solve for x. X equals negative b plus or minus the square root. B squared minus 4ac over 2 times a. So x is negative 7 plus or minus square root of 49 plus 40 all over 4. So we have two answers. We have negative 7 plus the square root of 89 all over 4. That's the first one, possible solution. And the other is negative 7 minus the square root of 89 all over 4. We can't take the log of a negative number. If you were to substitute x2 in, you would get a negative argument. Therefore, we only keep the positive, and we only get one answer.